I've got to make some important changes to the discussion of the boiling points of N2 and O2 from last night. You see, we remember that the answer was O2 has a higher boiling point, N2 has a lower boiling point. And I told you that that was because O2 having a higher molecular mass would have a larger atomic radius, giving you a bigger molecule, and that a bigger molecule is easier to polarize. And that is not really the way it works. So disregard that. But here's the way that that is meant to be understood. That O2 has stronger dispersion forces, that is, induced dipole to induced dipole attractive forces between molecules, than does N2. And the reason that it has stronger dispersion forces is just because it's heavier. And the rule, the take-home message, is that as your if you have a heavier molecular weight, then the heavier molecule is going to tend to have stronger London dispersion forces than the lighter one. That is, if the strongest intermolecular forces that you see between them are London dispersion forces. So if you're dealing with something that's nonpolar and the only attractive forces between molecules, the only thing holding the stuff together is induced dipole to induced dipole, also known as van der Waals, also known as dispersion forces. If that's the case, then a mixture of, not a mixture, but a heavier molecule is going to have there are going to be stronger intermolecular forces between molecules than a lighter one. So O2 is going to have a higher boiling point because it has stronger intermolecular forces than N2 does. And it's just because O2 is heavier. Don't worry at all about the atomic radius. For the record, atomic radius does get smaller as you go to the right on the periodic table. That's not always true. I've included a picture of a bunch of them, not in the video, but in a link nearby where you can see it. But a lot of times it gets smaller as you go to the right, and that's because things that are farther to the right in the same row have a stronger electronegativity, and they pull the electrons closer. So O2 is actually, or an oxygen atom actually has a smaller atomic radius than a nitrogen atom does. But the atomic radius is not what matters here. What matters is that O2 is heavier, so it has stronger intermolecular forces. If you want to understand why that is, I've included a little bit more explanation in some text stuff that I've associated with this video. It has partly to do with O2 having more electrons than N2 does. And there are a couple other things involved, and if you look closely enough, it can be really complicated. But for the MCAT, heavier stuff, stronger dispersion forces.